Welcome everyone. Welcome to the first GraphQL FM episode. Today we're having Dan Schafer on, co-creator of GraphQL, director of engineering at Facebook as well. This is our first show, so the goal of GraphQL FM is going to be basically to have very casual conversations, but also very in-depth, mainly just nerding out on GraphQL together. For those who don't know me, my name is Mark. I work at GitHub. Been playing with GraphQL for almost 5 years now. Very interested. Also author of a book called Production Ready GraphQL. So that's pretty much it. My co-host for these shows is going to be Tony Gitta. Do you want to introduce yourself?
Hey guys, I'm Tony. Hopefully y'all can hear me. Still trying to figure out this audio video stuff, but super excited to be here. Super excited to talk GraphQL. Something that we used to power Twitch. And we've been working on it for about 4 years. So super excited to get started and pick Dan's brain a little bit.
Yeah, so Dan, do you want to introduce yourself?
Yeah, absolutely. So I'm Dan Schafer, software engineer turned engineering director at Facebook. I've been at Facebook for about 10 years, and the project that I certainly worked on for the longest and the most proud of was one that started in 2012, collaborating with Levi Schrock to help create GraphQL. I worked on it internally from about 2012 to 2015, and then helped participate in the open source. And I'm still getting used to the fact that people have been working on GraphQL for 4 and 5 years. I hear that, and it's like, oh, you must have been at Facebook. And I was like, no. It's been open source for at this point significantly longer than it was internal only, and so it's always fun to see how it's evolving, and good to get the chance to chat about it with the two of you.
Awesome. So let's get started by I want to talk about how this whole GraphQL thing started, and there's this initial blog post that I think everybody's read when they're interested about GraphQL, and it kind of explains people were having issues with they didn't get the data they wanted. And I've always been curious, can you talk a bit about what the actual pains were in terms of using a REST API? Were people kind of building ad hoc endpoints? Was it kind of that kind of nightmare happening? Or can you kind of talk about specific examples?
Yeah, absolutely. I think looking back, and it really would have been at the end of 2011 and start of 2012 that this was the issue. We were taking our mobile app at this point, our iPhone app, which was primarily HTML5 based, and we were converting it to be implemented natively. And this is just a huge shift in terms of what your business logic looks like on a server. If you exclusively have a server that vends HTML, then at that point you don't have to worry about this concept of what is your API layer. You vend HTML, you render it either in your mobile app or you render it on your website, and you're in good shape. In introducing the native mobile app, we had to completely rethink this, and we did have APIs at the time. We had platform APIs, we had things like the Graph API and FQL, but these APIs weren't necessarily designed to build a complete Facebook mobile app. They were designed to allow platform developers to build the type of thing that platform developers would want to build. And so, as we started working on this iOS app, which I will probably refer to as Wild, it was the code name named after Oscar Wilde, we realized that these APIs that we had, the REST API, or REST-ish, because defining REST is a problem we could spend another 3 or 4 hours on, that API didn't quite work for them. And we also had FQL, but trying to build a fully featured Facebook client using FQL also didn't make a lot of sense, because you were fetching feed, and then you were joining it with the author, and then you were joining that with, what do you do with a story like Mark and Tony both posted on Dan's wall for his birthday? And you actually have 2 sub-stories there, and the sub-stories also have authors, and those sub-stories maybe have attachments as well, and you end up with this deeply nested hierarchy. And if you look at the views on a mobile app, or even views on a web page, they generally don't look tabular. Sometimes they do, and in those situations, SQL is actually a very good solution. But the Facebook newsfeed does not look like tabular data. It looks like a nested tree of data. And so the key realization that we had is we had this business object model at the ent layer, which effectively had this capability already. You could say, fetch me 10 stories using something called ent query, and then for each story I need to fetch the author and their profile picture. But we didn't have a clean way of exposing that through the API. And so when I think about GraphQL and its development in 2012, it really was developed almost as a thin layer on top of ent, and saying, hey, let's take all the capabilities that we have in our business object layer, the ability to basically fetch a tree, and then return that tree to the consumer that's going to turn it into a view, and give that to our mobile clients. And GraphQL really evolved iteratively from there.
Sweet. there's a lot of teams when facing that problem that will go a different route where they'll be, well, actually, let's empower our clients and have them build their own servers where they can build like more like page specific or like app specific endpoints. Did you ever consider something like that, or did you know it wasn't going to scale with like thousands of devs creating their own endpoints?
I think in many ways we had already had the developers create their own endpoints. We just didn't call them endpoints at the time. We called them events. Where, when I think about what the events team had done, the event team had already defined their data model. They had already defined end to event. They had already said that an event has people who have RSVP'd and maybes and declines. And this entire structure, honestly, a lot of what we think of as a GraphQL schema at the time, it already existed in this end layer. It just wasn't exposed over the API. And so in many ways, the thought was, rather than having you define a brand new endpoint or try and sort of define your API yourself, let's just give you the ability to opt into exposing this data model that you have in the business object layer into the server. And when I look at the evolution of GraphQL, this is proto GraphQL. This is, before even the super graph diff that has sort of become famous. It was, let's just build a feed endpoint. And let's build a feed endpoint that lets you not just query for feed stories, but like select fields down to the bottom. And that was sort of ultimately Supergraph. And the thing that I think, that diff from Nick really showed is, wait a second, we don't need to have, I was on the feed team at the time, we don't need to have Dan build a feed endpoint. We need to have Dan define the feed data model and then create a way of taking these arbitrary data models and exposing them over arbitrary endpoints. And that was really, that Supergraph diff and ultimately, GQL, which became GraphQL, is what emerged from there.
Awesome. Yeah, that makes a ton of sense. A lot of us focus on the kind of reducing payload side of advantage of GraphQL, but that kind of part of it seems much more than that, and like decoupling completely client requirements.
I think we were aware of the reducing payload side. And I think even more than that, we were aware of the reducing the round trip. But I think really the problem that we set out to solve wasn't, okay, we have a perfectly good way for client developers to think about fetching their data from the server, and it's just inefficient. It's just fetching too much data. It's just too many round trips. We were actually looking and going, we don't have a way for client developers to fetch their data from the server in a way that the client developers are saying, this makes sense to me. This is easy to use. They were either constructing these, artificial joins. There's a slide from one of the earliest presentations on GraphQL that, is a very simple feed that has like 17 left joins. And then you transform it into GraphQL core and it's like, oh, okay, I know exactly what that is. I think we really were focused, if not entirely, almost entirely on the experience of being a product developer, and in particular the experience of being a client developer, because at the time, native mobile development was not something that Facebook was good at. It was 2012. It's 8 years since then now. It was 8 years less mature just in terms of what it was like to be a native mobile developer. And I think our thesis was that they have enough to worry about. Let's not have them worry about, marshalling these multiple round trips or trying to go into www and, think about what their endpoint should look like. We want to make it as easy as possible to, build these apps and build these APIs.
Awesome.
It's I'm a little jealous that you started from this strong data model. At Twitch, we kind of have the opposite problem where we don't have this strong underlying data model, but we're using GraphQL to fake it until we do. So our story's kind of been the opposite, but used in the same way, I guess, to approximate that.
It's been really interesting to me as we open sourced it and as we went to talk with folks, we would go and talk with people about GraphQL and we'd be like, oh, this is what it does, and it wraps your underlying business, business object. And they'd be like, oh, okay, so about that business object. And a lot of what we realized is we weren't necessarily describing GraphQL as much. People generally got GraphQL. We were describing Ent and we were describing Loader, and that was actually the origins of Data Loader, which was we had gone to talk with people about GraphQL and spent a lot of the time talking about the sort of loader concept and the fact that yes, you could conceivably have an N+1 problem going from your resolvers to your backend, but if you had this abstraction, you wouldn't. And it was a little bit of the the air that we breathed at Facebook because we had this for so long. I think it was written by Nick Schrock and Ola in maybe 2009, 2010, that we were like, oh yeah, of course we have this. And I think that was a really interesting revelation for us that, we thought of GraphQL as being this very thin layer. It was this evolution of really what the product infrastructure org at Facebook, or product infrastructure team, because it wasn't an org at the time, had been creating just exposed over an API. And we realized actually that story of Ent, that story of Loader, that idea that you should have a single source of truth object in your backend is really valuable. And what's interesting to me as well is this actually touches a little bit on, what is at this point one of the great debates in, software engineering, which is microservices. Which is when I look at Facebook in its www layer does not have microservices, but it has hundreds, if not thousands, of product teams all working on it at once. And what do we do? And in many ways, the end layer is a little bit, your dividing line in terms of responsibility, which is if I'm working on events and Tony's working on groups, I'm just working on ent event and you're just working on ent group. And there, we actually have this really clear distinction. And especially with GraphQL, if I need to update my API, I just update ent group, I update my GraphQL definition, and I'm good to go. And there's a lot more to it than that. You need a really good release process in order to make sure that if I mess something up, I'm not holding Tony back from releasing his feature. But I do think the fact that we ended up with this clear data model and this clear sense of like, this is the part of this monolith that I'm working in, worked out really nicely. And then of course the big benefit that you get is once you're in that monolith and I say, well, actually this event could be for a group. How do I link these two things? Well, we're in the same code base and it literally is just, okay, cool. I'm adding a field that says event and you don't have any of the problems of, coordinating things across microservices, or where is ultimately your source of truth for a schema? Because your source of truth for the schema is the source of truth for all things business object. In this case, it's the Facebook www tier.
How much does a new Facebook employee need to know about GraphQL when they're started? Are they dealing mainly with the ent layer and not really caring, well, kind of like everything being taken care of at this point? Or are they thinking of GraphQL when?
It's been an interesting shift because, in 2011, there was no GraphQL. So you were exclusively thinking about ents, and we were, www.facebook.com was the primary interface that we were developing for because we were still a web company at the time. And that was server-side rendered. And so you would write your ent, you would consume your ent in XHP, and you were done. And I think looking at the last 9 years, the big shift now is, what are our primary clients? Our iOS app, our Android app, even the new Facebook.com that we're releasing is client-side rendered and powered by GraphQL. And so in many ways, and I think conceptually, has become a bit more of an implementation detail where it is, you're almost always consuming this through GraphQL. So I do think if you're a product developer at Facebook at this point, GraphQL is almost inevitable. One of the really cool things about the open sourcing has been oftentimes, how much do you need to know about GraphQL? Well, you've already learned it, from the open source world. I have a very distinct memory. It was like a year after we had open sourced it, and there was a post in one of our internal support groups, hey, I'm trying to figure out how to do this in GraphQL, and somebody commented and was like, well, I only started 2 weeks ago, but I'm pretty sure it works like this because I used it in my previous company. And I was like, holy smokes, like it was the right answer. And I was like, this is fantastic. Not only have we created this thing that, hopefully is going to benefit the entire engineering community, but it also means that people coming into Facebook, if you're coming into Facebook and you're going to go and work on www.facebook.com right now, we're asking you to work in React Relay and React Relay and GraphQL. Comet was sort of the code name that we had. You might already know that stack. You can come in and be like, I'm perfectly at home here. So and that's actually been a really cool benefit of open sourcing, even beyond the ability to give back to the community.
True. Are there like mismatches between kind of old school GraphQL Facebook build and the open source version? Are people surprised or not too much?
Not really. That's actually one of the things that happened in 2015 is when we went to open source GraphQL. We had I found it the other day. It was a document on my own laptop. What would we do if we could restart GraphQL again? Like, all the mistakes we made in 2012, 2013, 2014, which would we undo? And then come 2015, when we decided to open source it, we said, well, it's now or never. If we don't fix it now, then we're not going to. And, I would never claim that we got everything right, but there are certainly a lot of sort of artificial aspects of Facebook's GraphQL that emerged over time because, the original version of GraphQL didn't have a type system. It didn't have curly braces in the syntax. Like, it is a very proto GraphQL. You can see where it came from, but this is the type of thing that did not emerge, fully formed from the forehead of Zeus. This is something that emerged after 3 years of constant iteration by Lee, by Nick, by I, by plenty of other people at Facebook. We took a step back and were like, okay, if we were building it from scratch, what would we do? And, we got rid of, there used to be a concept of root calls that got eliminated, and that now is just root fields. If you actually go back and look at the original React Conf talk, you can sort of see some artifacts of this. We hadn't made that change at the time. We made some changes to how interfaces worked and your ability to query fields. You didn't have to spread on a concrete type to query fields, but that creates all sorts of gnarly downstream effects on what fields you can have, and that artificiality still remains. But mostly, if you are used to using GraphQL in the open source world and you come into Facebook, you're going to look at it and you're going to go, this is GraphQL as I'm used to. There are just 100 times more types than I'm used to.
That's awesome. You get it's such a awesome investment in open source, but then you're basically training people at this point elsewhere, and they come back and use that, and they're already up to date.
It's a tertiary or like a fourth order effect that, it's never why would open source. I never open source something being like, I hope that by doing this, when someone comes into Facebook, they'll already know the technology. But it is a really nice side effect. And, I think another one of the nice side effects is you just get to see how the open source world is handling a lot of these hard issues that we really never solved. One of the things that I've been, I think is just the coolest thing that's happened in the open source world is custom scalars. Because I remember working with custom scalars, must have been in 2014, and man, it was a pain in the neck. It was really hard to do internally, and I remember looking and going, there's got to be something better here. I don't know what it is. I don't know if I'm going to get the chance to work on it. And, to see the evolution in the spec and just how mature that ended up being and how nice of a solution ended up being, it's just absolutely indisputable at this point. GraphQL is better internally and externally for the fact that we've had the open source community work on it and develop things like interface inheritance and custom scalars and the work that's going on input unions. And so that's really been fun to see as well.
Awesome.
One of the things that sticks out most to me is that you've mentioned this a couple of times. I think in your talk in GraphQL Summit 2019, how there's kind of a prehistory to GraphQL, and you mentioned this briefly. I think you take it going back all the way to 2008, where you developed some of these practices like the tree structure, the asynchronicity of the execution. And what sticks out to me is just that how people have kind of hammered on this effort in this vein, on this concept to kind of refine it into this specification that's now like pretty common in the industry, I would say. I guess like my question is like, what kind of environment was that let you like think on a problem for several years, half a decade, almost a decade, or like, is there a team environment that lends itself well to that? Like,
yeah, no, it's a really good question. And I think, when I think about that team, the phrase that we used was product infrastructure, shortened to prod infra. And really the attitude that team had was, and this is sort of my formulation of it, there's almost this false dichotomy between how good an app can be and how productive developers can be in it. There's sometimes trade-offs like, okay, do you want this app to be as fast as possible? Write it in C. Do you want it to be even faster? Write it in assembly. Like, you can, but if you do something like that, okay, that is going to be much less easy for developers to use. Well, if you want it to be easy for developers to use, write it in this extremely high level language that's probably not going to be performant. And, I think of it like this production possibility frontier in economics, where it's just like, you're making these trade-offs. And the thesis of product infrastructure, at least in my mind, is if we build the right abstractions and we build the right frameworks, we will actually push that production possibility frontier. We can make it easier to use and we can make it a better app at the same time. And I think there's always been this thesis at Facebook, or at least as long, I was an intern in 2009, so that was my first exposure. It certainly existed then of like, yes, these investments are worthwhile. It is worth investing in, at the time, abstractions like Preparable, or abstractions like ultimately Ent, or things like GraphQL and React and Relay. Because we know that by building these things, the teams that build these things are relative certainly to the size of Facebook, extremely small, but they often are extremely leveraged. And so I think the attitude that the company had of, hey, this is going to be worthwhile is important. I also think the strategy that these teams used in building them was extremely critical. We refer to it as the prod infra playbook. Actually, Laney Zamor, who worked on GraphQL mutations and subscriptions, just wrote an awesome note internally that I hope we can get published externally because it's that good, describing this. And this overall thesis of when you have this big problem that you're trying to solve, you don't sort of say, I have a big problem that I'm trying to solve. I'm going to be in my ivory tower. I'll see you in half a decade. You take it and you go, okay, this is the big problem I'm trying to solve. I'm going to find a product team, find some user-facing, thing we're trying to build that will benefit from the first version of my solution. It doesn't have to be complete. When I think about, Nick in 2008 working on Ent, the idea that ultimately this would be a open source spec for an API layer to power mobile apps was not what was being trying to solve in 2008. He was trying to solve, a problem that product developers had. At the same time, there is sort of this overriding thesis of, but we have a philosophy, we have a theory of how things should work. I think if you look at Facebook's open source projects, I'm not giving anything away, we generally believe that by making APIs declarative, we're going to be able to make product developers more effective and make infrastructure developers more empowered. So to say, that the work that we were doing at any given point in time was pure local hill climbing ignores the fact that we did have these, longer term visions that we were trying to build out. But at the same time, we're really careful to scope these longer term visions and say, okay, how do we validate that we're getting there? How do we make sure that the thing we're building is actually going to be worthwhile? And the most successful projects that I've seen, even when they exist on the order, at this point, GraphQL has been around since 2012 or approaching a decade. At any given point in time, 6 months in, 12 months in, 18 months in, it wasn't complete. It wasn't where it is today, but it had already delivered some value to some product team where we could say, okay, we know that we're on the right track. We know we're building the right thing. And I think that's really important in that if you don't have a long-term vision, you end up just building short-term solutions and locally optimizing. But if you have the long-term vision and you don't find a way to provide incremental value, you risk really losing sight of things. You risk, the vision potentially being wrong. I think even as, I think back to that super graph diff that Nick had where he was saying, hey, this could eventually power the entire API surface area of the mobile apps. Yes, it did. It didn't look like what it looked like in that diff, and I think that's important. The idea was there, but the work that we did with the Newsfeed team on iOS and the Newsfeed team we did on Android, and eventually all the teams that used it, really informed what it became.
That's awesome. Yeah, if you just went in a room for 5 years and came out with GraphQL and be like, use that, probably nobody would have used it.
And that's, one of the reasons I like talking about sort of this origin and this prehistory. Partially it's one of the most fun periods of my life. It's, coworkers that I still am friends with to this day. And so of course I like talking about it. But I also think it's really important because, the history of GraphQL, if you start it from, the first time we publicly talked about it at ReactConf or the release of this, basically RFC of like, hey, we're thinking about this, you actually miss an important part of its development, which is it did not get created like that. It didn't get created as a spec and a reference implementation. It got created as an RFC that didn't land, followed by another RFC that didn't land, followed by a series of 3 diffs that built the world's most basic parser and executor, which were rewritten 3 times and added more features. And, to sort of think that like something like this can be created in one fell swoop, I feel like you almost always creating something that solves the problem you were trying to solve, and in the meantime that problem has disappeared, and only by iteratively moving towards something slightly better but with an end goal in mind do you ultimately end up with something like GraphQL. And so I think it's important to say this wasn't in February of 2015 Lee, Nick, and I had an idea and in June it was done full and polished. This was in 2008, we were trying to solve asynchronous data fetching. And in 2011, we were trying to figure out what a feed API would look like. And in 2013 and 14, we were trying to figure out mutations and subscriptions. And only then we're, in years of evolution. And, Lee, Nick, and I were sort of the original group that helped build in 2012. We were involved in the open sourcing in 2015. But if you look at the, changes that were made, the APIs that were developed, the, additional functionality, it's a group of, dozens at this point that really contributed to making GraphQL what it was, even by the time it was open sourced, and then certainly dozens, if not hundreds since then, that made it the community is today. And I think it's important to talk about that aspect to avoid almost this false narrative that the way that something like GraphQL comes about is what a single aha moment and a spec and a reference implementation, because that's certainly not the case.
Right. I'm always impressed by these stories because I know how hard making organization changes, especially to like developer facing tools is, and getting people on boards. I kind of want to take a question from the chat, Tony, because I really wanted to talk about that as well. Leigh Halliday asks, kind of if GitHub, Facebook, Twitch uses a code-first approach when we're building schemas, or something like an SDL-first approach. And maybe the additional question I had for Dan would be, kind of what was the role of the SDL at Facebook? Was it something that was kind of added later on? And did you ever think it could become kind of a definition language for a schema? Because I don't think that's how schemas are built internally, right?
Yeah, it's certainly not how they're built internally. I certainly never thought it would become what it did today. The origin of the SDL is sort of threefold. It originally was developed for our clients where we wanted to extend the schemas. So let's say you have a story and you want to add, the fetch time in milliseconds that it was fetched. Only the client knows about that. You really don't want to just like sort of put that in a random map somewhere, and you kind of wish you could just hook it onto the object. And so we added the ability to extend a type and say, okay, extend type story, there's fetch time milliseconds, it's a double, or I guess it would be a string or something like that. And here you go. And then ultimately, as we were open sourcing it, we ended up, I think, writing the spec and being like, boy, it sure would be nice if we had a shorthand to refer to all of these types. And we almost developed the shorthand. And then, it was Nick who was sort of like, wait, this should actually be a schema definition language. But when I think about the schema definition language, it really was never designed to, you defined this and then you define the resolvers. It was defined in order to say, let me extend a type where there truly is no business logic, or defined almost as an output of an existing schema. Hey, the introspection, result in JSON is great. It's great for tooling, but it sure would be nice if it was actually human readable. Let's have something like that. I actually, when I've seen SDL first approaches, I honestly, they've never quite resonated with me. I think when you're doing something like an introduction to GraphQL tutorial, it's extremely powerful, where you want to introduce the concept of the type system. You want to introduce the concept that there is a field, and maybe you're introducing non-nullability or the fact that you can have these queries, and you almost want to leave the resolvers at some point are an implementation detail if you're just talking about GraphQL. But when I think about sort of a long-term, a large schema, really the resolvers and the schema are inherently interconnected. There's sort of this concept of like separation of concerns versus separation of languages, which when I think about React, one of the things that React certainly did controversially is it said, wait a second, your markup and your view are separate languages, but they are inherently coupled. You can't really change the one without changing the other. And so it doesn't make sense to have them be in two separate files. When I think about something like Relay's approach to fragment co-location, it has the same observation. The data that you're fetching for a component and what you're rendering are inherently coupled. You can't change one without changing the other. So it doesn't make sense to have them be in separate files. Well, your resolvers and your schema are inherently coupled. If I say that I have a name and it returns a string, I can already tell you a ton of information about the resolver. The resolver better have a name and it better return a string, and I can't change one without changing the other. And so the idea that these should live in two separate files and both independently be a source of truth. If you have two separate sources of truth, either they agree, in which case you've repeated yourself, or you disagree, in which case you have a bug. And whenever I see that, I'm just like, okay, there should just be a single source of truth here. And the approach that we took in the beginning, because Ent was the source of truth, is we said, okay, GraphQL is going to be a wrapper layer. We're going to have this very GraphQL JS style, like, you define a resolver and you define this, and like the Ent is the source of truth. We now do annotations because really there is not that strong of a distinction between Ent and GraphQL. It's very rare that you would want to expose something in Ent and not expose it in GraphQL with our iOS, our Android, and our web clients while using GraphQL. I don't know that I would, if we have the SDL as a checked-in artifact on our native clients, it's something that you can view in order to see changes, as I think a lot of folks have done. But I don't know that I'd ever want to be human writing both an SDL and a resolver, because if I'm human writing both, I just inherently have to keep them in sync, and that doesn't seem to deliver a lot of value to me.
Interesting. Tony, what's your approach at Twitch? I know you're maybe more of an SDL first approach. Okay.
Yeah. I'm curious to hear.
Yeah, so actually, I think, so we're complete SDL first. So a little bit opposite, I think, more than most folks. But the reason is not really like the coupling, but it's kind of like a design tool. Like you can think without, I think very often we'll think like, what does my database look like? And that's not the same as like, what should the user experience be? So keeping it separate from the implementation lets us say, okay, like let's put on our product hats and work backwards from the user experience rather than like the implementation exudes out a schema. So I don't know if that's an artifact of like our weaker internal data model or.
That's actually that's really compelling, because when I think about, okay, what do we do internally? We design, to a certain extent, we would design the end first. And I think what we both said is sort of in the parlance of our own tech stacks, exactly the same thing. You should be thinking about the API that the product developer is going to consume first, and then everything else should be an implementation detail. Because we have this Ent layer in between, it makes sense to design for the Ent layer and be like, and just expose that in GraphQL. But if you don't necessarily have the strong business object layer, well, then GraphQL is your business object, and you want to implement that first. And then, if anything, the resolvers are an implementation detail that, I think almost of like Thrift or Protobuf, where you actually would just like code gen a header file. And like at that point, it is like that's the source of truth for the types, and the implementations are the thing that you're manually implementing over there.
Right, and that's kind of how we see it. So I know
that makes a lot of sense.
Funny. It's funny to take like opposite approaches, but end up at the same place.
I think it comes from the same desire, which is the desire to design the API for the product developer and then figure out how to implement it afterwards. And just like if that's where you're starting from, then you just look at your tech stack and figure out where you're going from there. That resonates really strongly with me.
Yeah. For us,
we do some.
Go ahead.
Oh, sorry. I just wanted to leave it off. Like it's not like a complete handwritten pairing. We do have some code generation.
Yeah.
It gets a little difficult to like map the specific backend calls. We have hundreds of services that we call, so opposite of monolith. That part is a little bit difficult, so that still requires a little bit of hand mapping. But yeah, it's not too bad. Definitely a little extra work.
It seems like whatever side you're choosing, you end up building tools to kind of fix the disadvantages you got from choosing that side. I think for us, it's kind of in between, where we're very, very decoupled from our kind of active record objects, database objects. And because we're a public API, it's also like we have to very optimize a lot for evolution, because deprecations or anything are so painful. So everything is decoupled, but it's also very verbose, because every GraphQL object has an object, and also our domain objects are objects. So it is a lot more verbose than if we had kind of a more annotation-based approach or SDL approach. But yeah, because of that, we have a lot of tooling to kind of like output cert SDLs, so it works with other tooling, and we're about it. So yeah, I'm also a fan of the code first approach because we can, whatever, if the SDL ends up evolving, because I know a lot of people are pushing to add features to it because it's becoming kind of a definition language. Well, because we're just using Ruby, then we can always output the right thing, and we can always kind of move with the SDL because our source of truth is in our control, which I like as well. But yeah, the SDL approach is really promising.
Yeah, and I ultimately, I always come down on do what makes sense in your stack and for your product. You know, when I think about the advantages that a place like Facebook would gain by going to an SDL first approach, it tends to be fairly minimal. Like we have the ability to look at SDLs that we generate based on our like, we've switched to sort of an annotation approach in the last 8 years. I look at some, the situation that Tony described, and I was like, it sounds like there are huge advantages to doing the SDL first approach because it instills this think about your object model one. And there's a little bit of, what are the nice things about the community, and the nice things about having these options is people can find their own truths and people can find the thing that really benefits them. And, to a certain extent, I think back where people are like, oh, should I use GraphQL for this? Just like as a top level question, I'm like, well, does it solve a problem that you have? Because if not, then no. And if so, then yes. And I think about these approaches like if it solves a real problem that you have in a good way, then it's probably a good direction, even if it's not the direction that other people have taken before.
That's kind of a good segue for something else I wanted to talk about is I kind of want to ask you, so we're seeing exactly what you were saying, people saying like, I'll just use GraphQL for this because GraphQL is cool. So we're seeing it just everywhere. Databases are starting to use it instead of SQL in certain places. We're seeing it used in tons of different contexts that are very, very different from Facebook's original. When you see that, what are your thoughts on GraphQL's usage, like being everywhere? Does it scare you a little bit, or are you excited about it?
Both. It scares me a little bit. I'm also very excited. I'm excited in that I think GraphQL is at this point being used to solve problems in really, compelling fashions that we never thought of. And that's one of the fun parts about open sourcing. It is, you get to see people using it in ways that make you go, whoa, we never would have considered that. I remember right after we open sourced it, somebody built basically a GraphQL schema that would take arbitrary HTML, and you could effectively do a DOM query using GraphQL. And it's like, hey, you're traversing a tree. That's really cool. I literally just pulled out all the links in this thing. That was really awesome. Is that what GraphQL is designed to do? No. Is it cool and a good use of GraphQL? Yes. So I'm obviously excited. I'm a little bit trepidatious because it also allows you to use GraphQL for things that it's not designed to do. If you have a bunch of tabular data in a database and you're trying to fetch tabular data with arbitrary filters and orders and sorts and joins, you're probably going to find GraphQL completely uncompelling and eventually say something like, I don't understand GraphQL, why wouldn't people just use SQL? In the same way that if you were trying to build something like Facebook Newsfeed, which requires deep nested tree structures and arbitrary filters and orderings are actually not something you want, you would look at SQL and go, this is massively over-engineered, it has a bunch of features I don't want, I want GraphQL. And the fact that in one context SQL is the right call and the other context GraphQL is the right call doesn't mean that one of them has failed or that we haven't expanded it to its natural place where it subsumes the other one. It just means that there are different problems and different solutions that apply equally. And so whenever I see someone, my favorite response when I see someone being like, I don't understand GraphQL, what's the problem it's trying to solve, is effectively people who go, look at the problem it's trying to solve. Look at trying to design something like Facebook's newsfeed, and you'll see it's compelling. And that to me is, I really like that because I would never aspire to have GraphQL be this one-size-fits-all solution. I don't think those exist. I think if you try and have it solve every problem, you probably end up having it solve no problems. But I am proud of the fact that I think GraphQL solved the problem that we were confronted with really well. And it's been really exciting to see just the extent in the industry that people encountered similar problems and found the solution similarly compelling.
It's always funny to me because the arbitrary data and filtering and slicing sometimes feels like it's the primary use case to some people, and they're like, oh well, that you don't get filters out of the box. Like, why do you use GraphQL? That's like completely not why you were using it. So yeah. I
mean, in many ways, it comes back to the name, which is, it was a running joke for the first year or so after open source, was GraphQL, not a graph database query language. Scott Walchuk, who worked on GraphQL in the other days, pointed out it's not an arbitrary query language and it returns a tree. So like both graph and QL are wrong. Fortunately, I think the name has become a bit of a proper noun on its own. I always found it amusing, and people are like, GraphQL is a terrible name, and I'm like, we're at a JavaScript conference. I think the name will be fine. Like eventually it will become this proper noun that people don't associate with the underlying parts and are like, okay, I understand what this is. I think it's gotten there, but I do think it did lead to confusion where, if you're just like, oh, GraphQL, so I should replace SQL for places where I'm, working with graphs. Yeah, you're probably going to run into confusion. And if you use GraphQL to, solve the problem of clients and servers communicating where the client needs to fetch an arbitrary tree of data, you'll probably find it really compelling. And there are things in between. When I see GraphQL being used for graph databases, and people are saying it's compelling, great. Like if it solves a real problem that you have, that makes a lot of sense. I do think as the community evolves and as the spec evolves, we do run the risk, and I think it's a good risk. It's one that we should confront of what do we do when multiple use cases of GraphQL have differing requirements where, GraphQL being used as a query language for a graph database and GraphQL being used to, power an HTML parser and GraphQL being used to power a public API for GitHub do have fundamentally different requirements. And it's one of the reasons why the continued health of the community makes me really happy, how active the working group is, and just the fact that the community really has rallied behind this idea that, if we work together, we will ultimately find something. And I think the fact that the GraphQL spec has evolved but slowly feels like a massive success case to me. I think if it had evolved, if GraphQL right now was unrecognizable compared to 2015, we would have failed because nobody wants their language to be completely unrecognizable 5 years later. If it was identical to 2015, literally identical, we hadn't changed the spec at all, we would have failed because that would mean that we're not taking in the new ideas. And I think we found this really good cadence, and I think it's to the credit of the community, and particularly to Lee, who I think has done a really good job of helping guide and shape the community over the last 5 years.
I was going to say, I think Lee did a fantastic job because there was so much pressure, especially in the first years of adding this, adding that. If Lee accepted like every of the PRs that were on the spec, I think we'd have like this language that does everything and like transactions and
It's a hard problem though, and I credit him a lot. I think it's a very tricky tightrope to walk, and I think he's walked it well for the last 5 years, and that shows no sign of changing, fortunately.
I completely agree. I think it's a massive strength of the project itself, just to have that kind of leadership that's kind of measured and patient, I guess.
Yeah.
I want. Sorry.
Were you going to another chat question?
Yes. Do we have another one, Tony?
Yeah. So this one's a little bit switching gears here. Thaddeus asked, when you're building out a very large GraphQL API, the schema can become unwieldy and hard to traverse. And Thaddeus asks, what do you foresee the solution to this, and proposes like schema stitching. So Facebook's got a pretty old, mature GraphQL API, I imagine now, probably fairly large.
Yeah.
Maybe you can say a little bit like how you manage that that growth. And maybe it doesn't have anything to do with GraphQL. Like, is it all something that Ent does, or?
Yeah, it's a tricky problem, and I think just the growth and evolution of a product and of a schema are inherently a hard problem. In 2012, Newsfeed was the very first thing we were building using GraphQL, and we needed a name for the thing that appears in a newsfeed, and we called it Story. And in 2012, that was just like a very obvious choice. It's a newsfeed story, and I think at this point, if you say story anywhere in the world, certainly at Facebook, they are not thinking of a newsfeed story. They're thinking of little pogs at the top that the entire world now knows as stories. That type is just badly named, and we'll never be able to change that. And I think you a little bit have to embrace that. In 2012, if you come to us and be like, by the way, you're gonna regret this, we have been like, pogs at the top of no, that's never gonna happen. So I think there is that aspect of the evolution. I think a lot of the solution here is, for me, tooling. Where when I think about something like graphical and the ability to search for arbitrary types, the fact that documentation is a first-class citizen in GraphQL, in this introspection and in the SDL, I think is really important. And so a lot of the way that we've gotten away with this is just by being really diligent about tooling and descriptions and making sure that we do realize names are one of the very few things you can't change. Back in, it would have been 2013, 2014, I gave a talk on GraphQL API design and wrote up a wiki, and literally the very first bullet point was naming matters. It was naming matters and description matters. That's like Everything else you're going to do in your GraphQL API design, you can a little bit get wrong and you'll be able to tweak it. But if it's named badly, no one is ever going to be able to figure out what it is. And I think folks have embraced that. We also have gotten to cheat a little bit here because we do have a PHP monolith, or at this point a hack language monolith. There are namespaces in there, but we traditionally don't use them. We traditionally are just like, no, like, name your class unique, and so you do have these, odd things where I don't even know what the name of the actual story at the top is in the end layer. It might be top of feed story or transit story or something like that. They couldn't take story because that was already taken, but we worked around that. And so, if you do have, 100 microservices, you probably don't have an underlying forcing function that says, hey, you can't name it the same thing twice in microservice alpha and microservice Zulu. That's going to be tricky because what do you do when you eventually merge them? And I think that's where schema stitching becomes tricky. That's where namespaces become tricky. And I do recognize sort of the the desire to try and solve that problem more generally. I think namespaces are a canonical example of one where is it conceivable to me that they would end up in GraphQL eventually? Of course. I think if they come up with a really compelling story of how we can add them, how we can progressively disclose that complexity, how they're just strictly going to make it better. I think the tricky thing is, the very first question we ask is, what would you do without them? And at least from what we've seen, people are able to work around it. And there is sort of a underlying complexity to adding anything to the system. So I think for me, it's all about tooling. There's almost no problem I've seen that can't be solved with sufficient tooling. And so even something like microservices, I can imagine an idea where effectively, if you're building a new type, it's just like you check that via tooling against all of the other GraphQL types you have and see if there's a conflict. Tooling that would, if you're merging things, just rename things. We had this on our iOS app for a long time because we needed to rename certain fields because we mapped fields to the names of selectors. But with 100,000 fields, occasionally those selectors are going to also be the names of Apple private APIs. And even if they're just an implementation method on an object, it's like, hey, like it looks like there's something with the selector. And so we would have a rename where, if first name was a private API for some reason, we would change the field name to user first name on the client. And again, tooling can solve a lot of these issues, and that's certainly what we've done.
What do you do to one of those problems I see often is like you'll have those kind of God objects like a user or maybe a friend, and everything ends up being one of those types. So you'll have like a user that's the viewer is a user, a friend is a user as well, and you start reusing that user object everywhere, and then you realize it's too late, but they start kind of diverging. Do you have that problem, and kind of how do you solve it? I've heard you name things very specifically for that reason.
Yeah, I mean, we got it wrong in the initial version. Originally, user both meant a user on Facebook and a logged in user. And so, for example, a user has a newsfeed, right? Cool. So user has a newsfeed, and a user has a name, right? Yeah, user name. And those are actually two different concepts because, if I'm looking at, the two users that represent your Facebook accounts, I can see your name. I certainly can't see your newsfeed. And so, in our layer, like if you tried to query somebody else's newsfeed, it would just fail immediately because there was no way to do that in the underlying infrastructure. But it was sort of this, artifact in the schema that was like, that really shouldn't be there. And so now we have the concept of user and viewer. And for user, you can give an arbitrary ID and get the user back. But for viewer, it takes no parameters. You are just getting your current logged in user. And that's where, newsfeed would be or notifications would be. And so that was one separation that we had to do. For user itself, it is a little bit of a large monolithic object just because there are so many things that need to exist on it. One of the things that we've done is we've tried to break it down by a little bit capabilities. So for example, on a group, we actually have a subfield called group admin info. And all of the things that you can do as an admin of a group are sort of nested off of there because there are a ton of those and we didn't want them to sort of pollute the group namespace. But in general, user probably has 300 plus fields at this point. And, the major way that we maintain that and make it usable, one is search. Fortunately, to the best of my knowledge, GraphQL avoids pretty much anything that's not linear in the number of types and fields because it was the only way we could make it work for Facebook schema. And so search works fairly well. And then the second one is if you are going to be adding a huge blob of fields, just like adding that artificial nesting object, if they, to a certain extent, it's almost field namespacing.
So one thing we've been struggling with sometimes is, for example, if you're a group admin, you might see more information on the members of the group that maybe another user would not be able to see, like if they have two-factor enabled or something. Do you use kind of different types for that, or just fields that will return null when you're not in the right context? Or
Yeah, contextual privacy is a really, really hard problem. Where what do you do when, when I'm viewing you in this context, I can see more information than I can in this other one, or less information. It becomes an especially hard problem with client-side caching. And actually, the client-side caching constraint almost forces a solution where, if in the context of, viewing you in a group, I can see your birthday for some reason, but in the context of viewing you on a timeline, I can't see your birthday because you chose to hide it. We just can't have those be the same objects, because if those are the same objects, we run the risk that with the same ID, we're going to overwrite in the cache. I'm going to go to the group. It's going to say, you can see your birthday now. It's on Mark's, birthday or user object stored. And then I go back to timeline. We're like, we can pull this from cache and show it. And so what we would do is we would effectively create a artificial wrapper object that is effectively like, this is Mark in the context of this group. And the only things you can see here are here's the link to his actual underlying user, but here's his birthday. And the only reason you can see this is because you had access to the mark in a member of a group, which you can only get if you're an admin of a group. One of the other really hard design challenges we had right early on was blocked users. What do I do if Tony has blocked me and Tony wants to go at the list and look at the list of people that he has blocked? We cannot load the user object, right? He's blocked me. But we have to, that is the one thing you can see about a user that you have blocked is their name and a little X next to it. And so you have to be able to see their name somehow and their ID in order to identify them. And so we literally created a blocked user object that all you can get is ID and name. That is it. You can see absolutely nothing else. There is no way to get any other information, but that allows you to build the unblock a user feature by being able to X them out. And so, that's another example of sort of contextual privacy in a case where just by introducing new objects into the system, you actually can, one, make it a little bit easier to design, and two, you avoid any sort of caching issues where you accidentally sort of cache something from one context and show it in the other.
And will you share common fields using like an interface, for example, or more like composition, or do you literally just copy everything you need?
Generally, and I'm a little bit designing on the back of a napkin here because I haven't done this too much. Generally, I would probably use composition, where if you can see more information than in this context than you normally can, then I'm just going to link to the user and be like, and by the way, here's the rest of it if you need it, and here's the stuff you can only see in this context. If you can see less, then you effectively have to sort of mask it. But in my experience, the cases where you can see less, it's very rarely that in every other context, you can see all of the data. And in this one context, you can't see this one piece of data. And it's going to be much more like the blocked user case, where in this context, you can only see these sort of very small sets of fields, in which case the mask is pretty easy.
Makes a ton of sense. Yeah, it's such a hard problem.
Yeah.
I want to move on to another subject that is kind of taboo, the whole microservices versus monolith subject.
Oh boy.
Tony, Twitch has kind of a microservice architecture, am I right?
Yeah, we have I think like 140 services that our GraphQL gateway server talks to.
Can you talk about how you do GraphQL with this? Like people are expecting sometimes stitching, federation. Is that something you're using?
It's not something that we're using. So we've kind of kept the GraphQL schema as a kind of a product concern, like going back to the way we do like SDL first, like this is how our product is, and how the services talk to each other really doesn't match that very well. Like you can have a service that, like the user service, that is used in many other services. So that focuses on, we define those interfaces using an RPC framework. We have our own at Twitch called Twerp. That's kind of like gRPC. And we use that for those service. That's the service communication language. So we don't try to put GraphQL everywhere in a stack. We try to just localize it into that one place. I think like I'm a little bit wary of the approach of like kind of putting GraphQL everywhere. I don't super see the benefit of that on the server side, where like usually the services are co-located in our data center. So network is a little cheaper, I guess. So the selecting a minimum data set, not super important, especially when you can have like a binary format, where format. So yeah, does that answer your question?
Yeah, totally. I think it's interesting because a lot of people in the microservice world will be talking about a kind of a stitching, trying to like separate the schema across those services, but you kind of have a monolith GraphQL API in a microservice context.
it's definitely, I think, a little backwards for the context. I think when you have these microservices, I think teams tend to kind of silo and want to keep control of that silo, which includes like how that data is exposed to the public. And I think that's kind of a little bit of an anti-pattern. So I think the API team at Twitch shares a little bit more burden in that like we have to kind of think in this like product like holistic sense when this team is like thinking like, oh, this is my feature. But not really thinking like what else is named this. Like Dan brought this up earlier. So our layer is kind of where we have those discussions about like how does this compose into our existing interface and how do we make it cohesive. I think that's a lot harder than just saying like you know what, you don't have to talk to each other, just like here's your schema, here's your schema, here's your schema, everyone gets a schema, and then like you hope for the best, which is completely reasonable. Like it may not be in a company's best interest to like spend a lot of time thinking about what the API is. If their API is not integral to their product, like maybe they just need I just need to pipe data through. I think that's a reasonable approach as well.
Totally.
And the interesting thing for me is at the end of the day, if you have a client, there is going to be one schema that the client sees, right? The client is going to say, this is your schema. And there's a question of, do you want that to be designed or do you not? And like, there's a little bit of like, if you want it to not be designed, that's a little bit weird because ultimately you're building the GraphQL API for these client developers. You probably want the thing that they're going to, be consuming to make a lot of sense. It should resonate with their way of thinking about the product. And one particular thing is certainly it shouldn't expose the microservices, right? The schema between the client and the server, you really don't want to reveal your implementation details if you ever wanted this microservices to be two or, combine these two into one, if you've exposed that implementation detail. And so at the end of the day, like, this SDL that we're giving to the client, this is the artifact that they consume of everything we've done on the back end. I would want to have editorial control over that. I would want to be able to say, hey, this is what is really going to resonate. This is how we think about the project. And then when I think about what do you do from there, okay, now you have this single source of truth that is your GraphQL schema. The implementation details are exactly that. We choose to say user maps to end user and group maps to end group. If you want to say user maps to user service and group maps to group service, that's fine. Effectively, all we've done is we've said we're going to have these be local method calls within an HHVM instance, and you're going to have them be RPC calls between two services. They have trade-offs. I will, I think my cards are fairly clear. I love the fact that we have the monolith. It is hard. It is hard to maintain. You need to have just this incredible amount of diligence around release cadence. The entire reason why the Facebook monolith was able to survive is because we released every Tuesday, whether you liked it or not. And if your stuff wasn't ready to go, it was getting reverted just relentlessly because we had to do it in order to release, because if the release started slipping, suddenly, my one change is blocking other people. You have to have this really strict cadence around feature flags where if you're developing in master, everything has to be feature flagged so that you are not getting reverted, so that you're not holding back the push, so that everything can continue to go out. There are all of these ramifications to having a monolith that, if you get them right, ends up being really powerful. The fact that, if Tony and my team start working together, I can just solve that with it's a method call. It's not even an RPC. There's no sort of push safety or you pushing, am I pushing. It's just like, cool, now these two objects are linked. I think it was super powerful, and I think it was responsible for a lot of why Ent was so successful at Facebook and GraphQL was so successful at Facebook, because ultimately these features are inherently connected. The fact that an event can be in a group, the fact that users are in both groups and events, like these things all do connect, and the fact that we could create that really rich graph where, if I was building, I'm thinking about building events, right? And there's like, shoot, how are we going to build this out? Well, user is already completely built. So that's just completely done. And connections as a concept are already built. So your ability to paginate through lists is already done. I'm not saying it wasn't a hard feature to build, but you really could sort of like bootstrap off of all of the existing work that had been done. And I think that ends up being, that is one of the sort of huge advantages of the monolith. And I think at the end of the day, if you are blindly stitching your schemas together from microservices, it's hard for me to imagine that the end output isn't going to look like you blindly stitch together the schemas from your microservices. And, as Tony put it, that may actually be a perfectly valid solution. You may say, this is going to allow me to build the mobile client I need to build. And, I go back to the start, which is if it's working for you, keep using it. But certainly, if I'm going to be building something where, the mobile app and the experience of being a mobile developer is the primary thing, they're going to spend an awful lot of time in that schema, and having an editorial or an authorial control is valuable. And I think one of the things that I think was really valuable about how we developed GraphQL at Facebook is, for the first year, Lee, Nick, or I pretty much reviewed every diff that touched GraphQL. And so to a certain extent, there was this authorial control. Yes, you can write your own schema, but at the end of the day, the three of us are saying, hey, by the way, this is generally how we design types. This is generally how we design fields. And so because of that, and then ultimately once you have enough types, everyone just copy paste them and keeps the same style and you're good. So even to this day, the Facebook schema does seem cohesive in a way that I think makes it valuable to use.
Do you ever foresee a future where some teams at Facebook start building their own service and they want to be part of that graph? And
it's an interesting problem because what do you do with Instagram and Facebook? Are these two things two completely separate graphs that never interact, or is the fact that I can cross post a story from Instagram to Facebook, does that lead to them? And interestingly enough, we're starting to run exactly into that now.
Interesting. Yeah.
It's a hard problem, and it's one that we're actually very much a little bit leaning on the community, which because of microservices ran into this sooner in order to inspire some of our designs.
Super interesting. Dan, I know you got to go top of the hour, so we're going to let you go now. I think there's so many other things we'd love to talk about.
Thank you so much for having me. This is a lot of fun.
Thanks a lot.
Yeah, I really appreciate taking time. Yeah, great job.
So yeah, thanks for coming on, and you're welcome back anytime.
Have a good one. Sounds good. Talk to you both soon.
See you then.
Thanks for watching, everyone.